Hello everyone. Today we will continue with motion at a constant acceleration in one dimension, and in particular we will focus on free fall that we started yesterday. So just a quick reminder, we took these two specific cases. In one case, if we are dropping it from rest, okay, so we leave it from rest. In this case, x initial is x at the origin, v initial equal to 0. We drop it, it will fall under the influence of acceleration, which is the acceleration will be the gravity. It will fall under the influence of gravity until it is almost reaching point B, where the position of point B is minus h, because it's in the opposite x-axis, and its velocity is v maximum. Okay, and what we want to remember here is the acceleration is always minus 10 meters per second squared, or minus gravity if we are on another planet. In this case, it will be clear in the question. So another scenario we can consider, if we take the ball, drop it upward, then it will fall. First, it will go upward, but then it will go up, then it will go down, and reach point B again. So what will happen while it's going up? While it's going up, it will be speeding down until it stops at point A. Then it will start falling again. If it stops, what does it mean? If it stops, it implies V at A equal 0. Okay, and this position of A, it is the maximum position it can reach. It's the maximum position it can reach. So x at A is equal x maximum. Okay. In this case, the ball will not go upward unless I give it a push. So I need to give it an initial velocity. I need to give it an initial velocity from the beginning. Okay, it's positive, which means it's positive velocity upward. So the ball will go, the ball or the particle or the keys or anything I'm throwing upward. Okay, one thing here to keep in mind is that the acceleration, whether the ball is going up, whether the ball is going down, whether the ball at any situation, the acceleration is constant. It's equal to minus 10 meters per second squared. And because this acceleration is constant, I can use these 4 rules where instead of A, I will put minus G. Okay, let's do an exercise together. This is page 5. This is page 5, exercise number 6. A student throws a set of keys vertically upward to his brother, who is in a window 4 meters above. Okay, 4 meters above. So what do I have here? Just a second. And so how can I get the pen? Okay, I'll just text. So what do we have here? This is 4 meters above. What is this? So let's always think in terms of, in these problems, if we look at the formulas, we have delta x, v initial, v final, acceleration, delta t. So whenever we want to solve any exercise, we just put aside v initial, v final, acceleration, delta t, or delta x. What is given here? What's given here is that v initial is 4 meters. Okay, this is given. Just change the color for you. This is 4 meters. Okay, oh, sorry, this is not the initial. This is delta x is 4 meters. Okay, so he throws the ball up, the keys upward. The brother outstretched his hand and catches the keys 1.5 seconds later. So what is this? What is this 1.5 seconds later? This is delta t. Okay. What else do I have here? Do I have the initial velocity? No. Do I have the final velocity? No, they did not say that it went to the maximum position. They just said he caught it at 4 meters, but there is no clue that he caught it when it reached the maximum position. So we don't know anything about the V final. But what is it we know? We know very well that acceleration is minus 10 meters per second squared. Okay, so I have A, I have T, delta T, I have delta X. Part A, what is the initial velocity what is the initial velocity? With what initial velocity were the keys thrown? This means what is the initial velocity? So he's asking me about the initial. So I have AT delta X and I want the initial. I look at my 4 equations, okay? I look at my 4 equations. Which equation has A, T, delta X, and the initial? A, T, delta X, and the initial. It's actually the first equation. I cannot use the second equation because there is no VF. I cannot use the third equation, there is no VF. I cannot use the third equation, the fourth equation, because there is no VF. I can use only the first equation. So delta X equal V initial delta T plus half A delta T squared. Delta X is 4. V initial is my unknown. Delta T is 1.5. A is minus 10. And delta T is 1.5 squared. I do the math here. 4 equal 1.5 V initial minus 10 over 2 times 1.5 squared on the calculator is 11.25. I take it to the other side, it becomes 15.25 equal 1.5 V initial, and I get my V initial. Okay. What was the velocity of the keys just before they were caught? So I need to get the V just before the brother caught the keys. So here I need to get actually V at A. Okay, so now I also have V, sorry, now I have the initial, okay? And I need to get the final. So which equation? I have A, T, delta X, V initial, and I need V final. We are actually free to use equation number 2 because it has V final, V initial, A, and delta X. I can use the third equation. I can even use the last equation. So the easiest one here, and we always use it, is V final equal V initial plus A delta T. So V at A equal V at O, because V at A is the final, V at O is the initial, minus 10 times 1.5. And I get that V at A is minus 4.83 meters per second. Is this a mistake, or this can actually mean something? This is not a mistake. This indicates that the velocity when the brother caught the keys, it was downward. So this means that first he hit it upward, okay? It went up, 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 up. And then on its way down, that's where he got the ball, the keys, okay? On its way down, he caught the keys. So let's again just think about the exercise. I'm on the top of it, I'm on the ground, and I throw the keys upward to my brother who is at the window, okay? And he caught it after some time, and I get how much is the velocity when he caught it, and this is telling me that he caught it when the keys were falling down. So he missed it when it went up. He caught it on its way down. So if I get the velocity is negative in these exercises, it means the ball or the particle was, or the keys, it was going downward. So there is nothing wrong here. Okay, let's do another exercise. Okay. Okay, let's do exercise number 2, page 9. So once you look at the problem, you can see that this is a free fall problem. Okay, so this is a rocket here going up, going down. So this is also, it might be a free fall problem. Let's read the problem from the booklet, because all the information is actually on the plot, on the figure. So I didn't write that exercise. So there is a rocket that was traveling straight upward at a constant velocity v initial equal 80 meters per second. So in the beginning from C to O, it was going at a constant velocity. What does it mean that it's moving with a constant velocity? What does it mean? How much is the acceleration? If it's constant velocity, then the acceleration is 0. This is from C to O. Okay. Before it runs out of fuel. So at O, it runs out of fuel. There is no fuel anymore. And that was at the height 8,000 meters, which is at point O. Okay. The rocket then continues its vertical motion, reaching its maximum height. It's true that it ran out of fuel, but it will not stop immediately. It will keep moving a little bit until it reached the maximum height, A, before turning down in a free fall motion to the ground. And then it started falling down with a free fall to the ground. So I have to imagine this problem as two parts. The first part from C to O, constant speed, acceleration is 0. And the second part, it's a free fall because it's going under only the effect of acceleration. This is when it went from O to A and then from A to B. Over here, he called this axis x-axis, this axis y-axis. I don't want you to get confused. So I will just say that this is still x-axis, and I forget about this axis because actually we will not use it that way. So we will still say that this is x-axis, okay? And this I will just forget about. Let's see what information do we have and what is he asking for. So what information do we have? So I will put here V initial, V final, delta acceleration, delta x, delta t. I have the initial. I have the initial. This is V at O. This is 80 meters per second. I have acceleration. How much is the acceleration? It's minus 10 meters per second squared. Okay. So part A. So this is the information I have. I have the O, 80 meters per second. I have the height as well. I will keep it on the graph. For now, I may not need it. And I have the acceleration minus 10 meters per second squared. Part A. Part A, he's asking me to calculate the maximum height. So what is he asking for? He's asking for delta x. Okay. So he's asking for the maximum height. So he's asking for this distance from O to A. Okay. So what other information I have between O and A? I have the information that it stops at A. So I have that VF, which is VA in this case, VA is equal to 0 because it stopped. And the first part, I need to determine delta x. So I look at my equations. Which equation has V initial, V final, A, and delta x? Again, it's the second equation. Notice that the questions keep repeating. So if every time I redo the problem, I do redo the problem, these equations will get stuck in our mind. So I'm gonna use V square final equal V square initial plus 2A delta X. V square final is 0. V square initial is 80 square. A is 10, so 10 times 2 minus 10 times 2 minus 20 delta X, and I do the math. Okay, 20 delta X equal the square of 80, and then I get OA from O to A. Okay, you can also just call it delta X. Part B, how long from O does it take the rocket to reach its maximum height? It's asking me about delta. Now I have delta X, and it's asking for delta T. So which equation shall I use? I have V initial, V final, acceleration, delta X, and I need delta T. I can use any equation that has delta T. This includes equation number 1, equation number 3, equation number 4. And as usual, I'll use the easiest, which is equation number 3. V final equal V initial plus A delta T. V final is 0 because it stopped at A. V initial is 80 because this is given. And acceleration is minus 10. I get delta T. Okay. Part C. How long from A does it take the rocket to get back to the ground? So now I'm no more from A to B. Now I'm no more from O to A. Now I'm from A to B. Okay, so from A to B, let's see what we have. So what are our VA, VB? Let's see what we have from these values. Delta X, delta T. Okay. So what do we have? We have delta VA. How much is it? This is 0. Okay, meter per 0. It's okay. Do we have V at B? No, we don't have it. Do we have the acceleration? Yes, it's minus 10 meter per second square. Do we have delta X? Do we have the distance from A to B? Do we have it? Yes, we have it. It's OA. Or let's say it's AO plus OB plus OB. The only thing I have to pay attention is that this is in the negative direction. So this delta X is actually minus AO plus OB. Okay. Do I have delta T? No, I don't have delta T. And the question actually is how long? So this is my unknown. This is my unknown delta T. So let's look. I have VA, I have the initial, I have acceleration. Okay, I have delta X, and I need delta T. Which equation I can use? Let's try the first one. Delta X, I have it. Okay, the initial, I have it. Delta T is my unknown. Okay, acceleration, I have it. Delta T is my unknown. So I can use equation number 1 actually. Let's try and see if we can use another equation, maybe an easier one. Equation number 3. Do I have the final? No. V at B, I don't have it. Do I have the initial? Once I don't have one of them, then I cannot use it. Same thing about the last equation. I cannot use it because I don't have VB. So I only have one option, which is equation number 1. Okay, so here I just did the calculation, which is delta X from A to B is minus 8,000 plus 320. Okay, AO is 320. I calculated it, and OB is 8,000 because it's given in the drawing. This is the height where the rocket lost its gas, its fuel. So I have delta X from A to B, it's minus 8,320. Again, it's minus because X-axis is upward and A to B is downward, so it's minus. Now I will use the equation delta xab is half a delta t squared plus va delta t ab. This is minus 8,320. A is minus 10. Delta t is my unknown. VA is 0, so this disappears. Now I just do the math. Minus 8,320 equal minus 5 delta t squared. Delta t squared equal 8,320 over 5, which is 1664, implies delta TAB is a plus or minus 41 seconds. Okay, when a quantity square is equal to something, it means the quantity without a square is a plus or minus that something. But time is always positive. And this is why delta TAB is 41 seconds and not minus 41 seconds. Part D, how long does it take the rocket to go from point C to point O? Okay. Remember, from C to O, this is not a free fall. Actually, it's not a free fall because it's not running under the influence of gravity. From C to O, it's actually going because there is a fuel and they are putting يعني داعسين بنزين وطلع from C to O. Okay, so it's not traveling under the effect of gravity. So from point C to O, what I know is that from the question, it was traveling with a constant speed, So I just remember the equation for constant speed, V equal delta X over delta T. So V delta T is equal delta X, okay? V, I know it's 80 because it was 80 until it reached O and ran out of fuel, and then it started decreasing from there. So it was 80. Here I do cross multiplication, 80 delta T equal 8,000, delta T equal 100 seconds. Okay, someone might ask me, what if I forget this problem about constant speed? You can use any from these 4 equations. So what do you have here? You have, if it's constant speed, so I have the V, so what do I have here? I have the V, right? I have the delta X, and I have the acceleration because it's 0. I have it. And what's the question asking me for? It's asking me for delta T. Okay, so what equation here I can use? I go up, the first equation. Delta X, I have it. The initial, I have it, 80. A is 0. So if I just put delta X equal V initial delta T, this is exactly this equation. So you get the same answer, okay? So this is the end of today's lecture. If you have any questions, any concerns, just send me an email, and see you next week.